Let's continue multiplying permutations, but this time we will have more than two permutations to be multiplied, but still we will have the same permutations on S6. We have the sigma, tau, and mu. Again, we cannot just multiply permutations of different lengths or permutations of a different set, because we need to have the same number of elements before we can multiply permutations. Now let's start with the first here, because we might have a very lengthy discussion since the third example here involves a certain inverse. So let's have the mu times sigma squared. Of course, sigma squared means we'll just have mu times sigma. That would mean we will have our mu. So our mu is 1, 2, 3, 4, 5, 6. So the mapping is 5, 2, 4, 3, 1, and 6. Our sigma, 1, 2, 3, 4, 5, 6. You have 3, 1, 4, 5, 6, and 2. And since we have two sigmas here, just simply copy 1, 2, 3, 4, 5, 6. We have 3, 1, 4, 5, 6, 2. We have three different permutations now, but the same process will be followed. We are going to do it from right to left. So this next product of permutations will be moved a little bit in the bottom or later, as well as this, because we don't have much space. So please be guided with that. So you will have here, the result is still a permutation on the same set S6. Let's start from here. 1 map to 3. Next, 3 map to 4. And then 4 map to 3. In short, 1 is mapped to 3. That's the process of solving this. Next, we will have here 2 map to 1, 1 map to 3, and 3 map to 4. So 2 is mapped to 4. Next, you have 3 map to 4, 4 map to 5, 5 map to 1, so 3 map to 1. Then 4 map to 5, 5 map to 6, 6 map to 6, so 4 map to 6. 5 here is mapped to 6, 6 is mapped to 2, 2 is mapped to 2, so 5 is mapped to 2. Then 6 is mapped to 2, 2 is mapped to 1, 1 is mapped to 5, so 6 mapped to 5. As you can see, no repetitions of elements here, because again, for this to be called a permutation, it's both 1-to-1 and on-2. So let's duplicate the same process for this item here. So you have tau squared and sigma. In short, this is actually twice your tau and your sigma. So your tau is 1, 2, 3, 4, 5, 6. We have here 2, 4, 1, 3, 6, and 5. Another tau, 1, 2, 3, 4, 5, 6. You have 2, 4, 1, 3, 6, and 5. And your sigma is 1, 2, 3, 4, 5, 6. You will have 3, 1, 4, 5, 6, and 2. So same thing as earlier, we are going to work on it from right to left. This is still a permutation, 1, 2, 3, 4, 5, and 6. Let's start here. 1 map to 3, 3 map to 1, 1 map to 2. So 1 map to 2. Then 2 map to 1, 1 map to 2, 2 map to 4. 3 map to 4, 4 map to 3, 3 map to 1. Then 4 map to 5, 5 map to 6, 6 map to 5. Then you will have 5 map to 6, 6 map to 5, 5 map to 6. And finally, 6 map to 2, 2 map to 4, 4 map to 3. This is the product of the second expression. Now, let's proceed to the last one. As I mentioned earlier, we also need to add one discussion here pertaining on the concept of the inverse. Since we have here the product of the inverse of sigma times mu and times your tau. We don't have the inverse of sigma here. What we have is a sigma. Let me write here sigma. I believe this it was sigma earlier. So you have 1, 2, 3, 4, 5, and 6. So 3, 1, 4, 5, 6, 2. Let me check here. 3, 1, 4, 5, 6, 2. Okay. So how do we show the inverse of sigma? Now, we know that the product of a certain permutation to its inverse is actually equal to an identity, because the set containing all permutations is considered as a group. In short, there exists the idea of inverse such that sigma times its inverse is equal to your identity. Okay? Let me use here the notation for identity. We usually call it general, for general permutations, rho sub 0. Right? The product of a permutation to its inverse is equal to the identity. In short, this will just be equal to 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6, because an identity permutation is where the elements are mapped to itself, just like this one here. Okay. So if this would be our sigma, what would be the form of our inverse? That would mean that the form inverse of sigma is also a permutation 1, 2, 3, 4, 5, 6 in such a way that if we are going to multiply the sigma, the inverse of sigma to sigma, or of course we have the idea of a group where this is also the same as that, right? Okay, but nevertheless, the point here is that, say for example 1 mapped to 3, so this 3 here should return to 1, such that the product of the two permutations will have 1 mapped to 3, 3 mapped to 1, so you will have 1 mapped to 1. As for your 2, 2 mapped to 1, so your 1 must also be mapped to 2, such that your 2 here will be later mapped to 2. Just like that here. Then, one more. If you have 3 mapped to 4, so your 4 must also be mapping to 3, such that your 3 here is just mapped to 3 when these two are multiplied and achieve this one here. Just for these 3 examples or illustrations, look at what happened. 1 mapped to 3 is actually this reverse here, 3 mapped to 1. These two here. So you can see 1 mapped to 3, 3 mapped to 1. Next, if you have your 2 mapped to 1, that's 1 mapped to 2 as well. Okay? Next, your 3 mapped to 4 is also 4 mapped to 3. If you can see already the pattern, here's the thing. The inverse of a permutation is just a mapping to a reverse mapping to itself. Okay, reverse mapping. Say for example, 1 is mapped to 3, right? So its inverse is where 3 is mapped to 1, just like this one here. So if you have 2 is mapped to 1, so its inverse is where 1 is mapped to 2. And if you have here 3 is mapped to 4, so its inverse is where your 4 is mapped to 3. See that one? This would mean, for a clear concern, your what you call this one, inverse of sigma, where this is your sigma, 1, 2, 3, 4, 5, and 6. So since 1 is mapped to 3, or you could see here at the bottom where is 1, so 1 should be mapped to 2. Your 2 should be mapped to 6. Your 3 should be mapped to 1. Your 4 here should be mapped to 3. Your 5 is mapped to 4. And your 6 is mapped to 5. If you're not yet convinced, of course, you could always multiply this. Sigma and sigma are its inverse. You have 1, 2, 3, 4, 5, 6. Your sigma again is this one here, 3, 1, 4, 5, 6, 2. And your inverse is this one here. So 1, 2, 3, 4, 5, and 6. 2, 6, 1, 3, 4, and 6. Let's see if we're going to multiply this, of course, from right to left. We will return to our identity. the row sub 0, because that should be the idea of the product of a permutation to its inverse. So let's start. 1 map to 2, 2 map to 1, check. Let me use here other color. Check. The first mapping is checked. Next, you will have here 2 map to 6, 6 map to 2, that's 2 map to 2. 3 map to 1, 1 map to 3, that's 3 map to 3. 4 map to 3, 3 map to 4, that means 4 is mapped to 4. 5 map to 4, 4 map to 5, that's correct. 6 map to 6, sorry, this is 6. By the way, sorry, I am wrong here, by the way, earlier. Let me go back here. Sorry, that's my bad. Inverse 6 map to 5. Sorry. Okay. So this is 6 map to 5. My bad. Pardon. If you have 6 map to 5, 5 map to 6, achieve here as well. Sorry, this is why was my mistake earlier. So that's also another thing for you to know whether you are incorrect or not. So basically, again, as mentioned, if you're going to solve for the inverse of a certain permutation, just simply use the reverse mapping. So once we are now sure of this to be our inverse, let me go back here to the original item. Our original item is the inverse times mu times tau. Your inverse is this: 1, 2, 3, 4, 5, and 6. 2, 6, 1, 3, 4, and 5. So we multiply to your mu. Where's our mu? Sorry, I cannot memorize all the entries. So mu is actually this one here. Okay, 5, 2, 4, 3, 1, 6. Sorry, 5, 2, 4, 3, 1, 6. 5, 2, 4, 3, 1, 6. That's 1, 2, 3, 4, 5, 6. Let me check. 5, 2, 4, 3, 1, 6. And your tau, 2, 4, 1, 3, 6, 5. 2, 4, 1, 3, 6, 5. So 1, 2, 3, 4, 5, 6. Again, tau is 2, 4, 1, 3, 6, 5. Sorry, I just memorized it. So again, we can now simply say right to left, since we are already sure of this, our inverse of our sigma. Let's start. 1 map to 1. 1 map to 2, 2 map to 2, 2 map to 6. So 1, 2, 3, 4. That's 4, 5, 6. So 1 map to 6 again. 1 map to 2, 2 map to 2, 2 map to 6. 2 map to 4, 4 is mapped to 3, 3 is mapped to 1. Then 3 is mapped to 1, 1 is mapped to 5, 5 is mapped to 4. 4 is mapped to 3, 3 is mapped to 4, 4 is mapped to 3. 5 is mapped to 6, 6 is mapped to 6, 6 is mapped to 5. And then 6 is mapped to 5, 5 is mapped to 1, 1 is mapped to 2. This is the result for this expression. So we just added here the idea of the inverse so that we would understand what would be the form of the inverse of a certain permutation. So with all of this, we are done with multiplying permutations. Thank you very much for watching.